Hello friends and Namaskar. I am S.G. Kulkarni, retired Associate Professor, DKT's Textile and Engineering Institute, Ichalkaranji. We had seen in the earlier presentation, that is the basics of carding, part 1, we had discussed some of the aspects related to the carding department, carding machine in the spinning industry. There, I had discussed, if you recall, about the some of the basics of carding operation. Now, actually, we will start here in this particular presentation where we are, say, where we have left. So, we'll go directly to the passage of carding machine. Passage of material through card, the various aspects in this we had already discussed. So let's move ahead now. Operation principle of the carding department, carding machine rather. Now, here we can see in modern installations, raw material is supplied via duct, a chute feed system. So, we are feeding from the backside to the carding machine. Here we can see the duct which is supplying this. So all the manufacturers in today's situation, whether it is LMW, Ritter or Tuzler, they are utilizing feed regulating mechanisms at this particular point. Feed regulating mechanism in the sense, partly I had thrown some light on the auto leveling, what takes place on carding, and what is the need open loop, closed loop, etc. Where what is possible, etc. etc. We have discussed about that one. Now the difference as compared to the lap feed system on the carding machine and the chute feed system being, we are getting here a regular feed, regular bulk of the material, which was very difficult to obtain when the lap was prepared on in the blowroom department. That in the auto leveling, rather the blenders in the blowroom department and the chute feed system in this particular machine, the carding machine, where we can have a regular flow of the material. And one can see here, of course, we have the unidirectional feed, correcta feed, etc. Various names are there for these mechanisms. Now, what we can have here is a sensor is there. A sensor will sense, which was there on the very conventional card also, which was there in the card also, which was there in the blowroom. In fact, very conventional orthodox blowroom, piano feed regulating motion was there. Actually, the principle is derived, one can say, from that particular consideration to sense how much amount of material is passing, coming at a given instance, and in that conjunction either increase or decrease the feed speed, increase or decrease the feed speed. That's what is the basic of this particular operation. So what happens is, once the regular flow of material is obtained, of course this is indirect sensing. At the sensed position, what seen is observed, according to that the rectification action is taken, the corrective action is taken. So there might be some ambiguities in this one, some irregularities are likely to pass, but overall this gives a very excellent regular flow to the feeding zone. We have seen the three zones in the carding machine. In fact, there are four, but primarily there are three zones. So in the feeding zone where licarin or teichorin breaks apart the tufts, breaks apart the tufts in the sense it does not directly damage the fibers, but a reduction takes place, reduction of the mass takes place here. So when the reduction of mass takes place, at that time, on a regular material, if the reduction of the mass is exercised, it is executed, then it will give a very regular amount of feed to the cylinder of the carding machine, and which will reflect in the further sliver quality. So that is what the importance of the feed zone is there. Now the same is depicted here, various parts which are taking involved while this is done. So on modern carding, you see now here the spring loaded feed system is there, feed plate, assisting plate is there. Then you have a sensor here, you have a sensor here, transducers are used here so that the regular flow of material will take place, and that sensed material which is now being regulated, which will be taken to the Teichorin zone here. So this interaction one, this is a magnified view of the interaction between the Licarin wire and the cylinder wire is shown over here. These are the stationary flats here. These are the stationary flats on the back side instead of the back plate, and these are the stationary flats on the front side. And then a enclosed environment is created here. The flats are there, the cleaning system for flats. Again, the exaggerated or magnified view is shown over here, how the points are acting against the point, cylinder points are acting against the points of the flats. The direction of rotations, they are very absolutely important. They are also depicted here in this diagram. And then doffing arc, what is responsible for transfer of material from cylinder to the doffer, that is also shown in a magnified way here. So one can see cylinder is rotating from back to the front. This Licarin or Teichorin and doffer, they are moving exactly in the opposite direction. Then further condensing system and stripping condensing system, and then material is taken to the auto doffing type can, because you can see the cascading wheels here at the bottom of the can. So that will be, once this material, the can becomes full, it will be doffed, and in place of that a fresh empty can will be inserted here. So that's what the earlier we had seen about the importance of feeding zone and various things which are taking place overall in the modern carding machine. So let's move ahead. Operation principle of the card. Actually, we had already discussed in case of the conventional card about this one, left fed system. We have already seen this one. So the transport roller 3 passes the material to the feeding arrangement. So where the plate is there and the feed roller is there, and feed plate designed to push the fiber slowly into the operating range of the Teichorin or Licarin while maintaining the optimal clamping. Optimal clamping means this is a snug fitting here in between. So this is the regulating system which regulates the material, amount of material that is traversing. This is the waste collection system. Waste collection system. This is again a vacuum here, waste collecting system here. And once they are snugly fitting and regularizing the material, the action of the Licarin plays a vital role here. So this is what is we can see through this diagram. Now operation of feed, again, regions of our prime interest is what regions are there, how they form their particular, say, role here, how they play their role here. Now this is a sort of a Trussler system. Once this balloon you see, it is a Trussler system. Whether it is a single Likkerin or tri-Likkerin system, that is a different thing. But once this kind of a system you see, they have applied their principle here. So A, B, C, these are the grid elements. A, B, C are grid elements which are below this Likkerin. So they have gone for nearly only in the earlier days, in the conventional days, only this much portion, say 20-22% portion of the Likkerin, in fact 15 to 20% one can say, was covered by the grid bars, the knives. Now here they have gone for one more grid element, and which is assisted by a suction system. This is the suction system, what balloon type of a thing one can see. So once your feed ruler is feeding to the Likkerin and the feed plate is gripping that material, here they have a different system. In the Trussler arrangement, you can see the feed plate is above. Here feed plate they have maintained below. But this feed ruler rotates like this, and that is going against this one. So this will be slightly enhancing the action of this Likkerin. So this is the 3 is the Likkerin or Tekkerin, and then 4 is the main cylinder. So this is operating principle change in case of the Trussler system. We are basically discussing say two systems, Ritter and Trussler. So we can differentiate also. Differentiate from technological point of view. We are not going to comment on the company, their belongingness, etc. Other things we are not interested in here. We are interested in what technology they have adopted and what it can do to the carded materials. That is our main intention here. So this is the basic fundamental difference between the Ritter system and the Trussler system. The other things like the feed chute, etc., they will be having the same kind of a arrangement in case of the Trussler system also. So let's move ahead now. Once we have seen about the feed zone, now here slight elaboration, as I have said, here in the Ritter system, the 7 is the suction duct which will carry the waste. Flocks themselves are carried along with the main cylinder to the flats here in this one. Of course, this numbering is not very correct. That will be taken here and are open to the individual fibers between two devices in actual carding process. 10 is not this one, actually 10 should have been here. Once when we are terming them as flats. So this 10 appears here actually. So that already we have discussed in conventional machine. So the flats, as I already have also discussed, 80 to 116. Now these number of flats are required in this right side of the diagram, right side diagram. One can see here clearly the 10. So that is representing the flats here. And this is the flat chain. Entire thing is the flat chain. These rollers, they are responsible for linear movement across this bend above the cylinder, and rest of this, these are the tensioning rollers or supporting rollers, and this is where the cleaning of flats will take place at number 11. So these are the brush, these are the two brushes which will keep the flats clean, because in the regular journey trajectory Once the flats, I already last time discussed about this one, only the number was different. In the conventional we were having high number of flats. Here number of flats are reduced, and then once they leave the last zone, last part of the working cylinder in contact with them, then they are full up, they have made themselves full with the whatever waste, etc. Flat strip waste, already I have discussed about that one. So they are carrying that waste, they are embedded with that waste, so that is to be taken clean, and then slight burnish, harsh brush will be acted upon on them, and then that will keep the wire points on the flat very clean. So that's what is the job done in case of this particular zone. These 30 to 46 flats are located in the carding position, which is in the vicinity of the main cylinder. These are working flats. So total number of flats and working flats. This is what is the statement here in case of this one. Now already we have discussed about operational principle of the card, that the flats are that they are designed in such a way that they are going to have the interaction of wire points, and the carding bars here, which are shown at 9 and 12, designed to assist the carding, so actually this 9 is here and 12 is here at this particular place, to be very accurate. So these are the two places. These are the covering plates, which are stationary flats. Some of the people, they call it as stationary flats, and they will assist indirectly. They actually, some people term them as, some researchers have quoted that they are doing the combing operation on the carding machine. So that's what is the this particular thing. Cylinder and flat, already I have discussed, just now also stated this thing, that the carding action will take place basically there. Now, once the carding operation is done, again I have discussed the same point in the conventional card also, lap feed card. The cylinder is carrying the fibers, and they are normally without hooks. They are straightened to some extent. However, this condition of the fiber is not transportable to the intermediate product. An additional cylinder, or cylinder in the sense the doffer, is required for this purpose. Means, in other words, directly whatever material is carded, once we have fed here, it will be say right from here to this particular place, carding will take place in this region. Now here, somewhat in the feeding side, on the feeding side, this will slightly tear apart the stationary flats, wire covered flats. They will slightly scratch, one can say, tear apart or scratch those fibers which are trying to go in the carding zone. And then once the carding is done, now the segregated stage has nearly obtained the basic layer and working layer. There are two layers on the cylinder. What, say, last session I have discussed, one fiber will go around some 20-24 times, etc., on the cylinder. It will not be directly delivered onto the doffer. The meaning is, there is a basic layer that is formed, and there is a working layer, and this working layer is transferred. Basic layer will remain as it is. The fibers will only exchange themselves, and some fibers will form the basic layer and some fibers will form the working layer. and this working layer gets transferred onto the dopper. But for that, we cannot deliver this carded material directly to the further system. So we need to have a dopper, a wire covered big ruler. That's what is the statement here. So from that working layer, we normally calculate the transfer efficiency. So part of the total material fed in to the cylinder, the Q, capital Q one can say, the part of the total fed material is Q, and part of that material gets transferred is the small q. So this small, at a given particular instance, this small q divided by capital Q into 100 is transfer efficiency. In very simple words, amount from what amount of material, available material, how much amount of material gets transferred on the dopper at a given instance is transfer efficiency. And this was, in the conventional card, this was less, 10, around 10-15% this transfer efficiency. So efforts were made, and because this what I have mentioned in the previous session, that the speeds were increased because of certain reasons, because of this transfer coefficient or transfer quotient, that increase per instance, the speed of the card has been enhanced drastically. So transfer efficiency has increased. It goes 30-40% now. So of the total fed material, 30 to 40% of the material will get transferred at a given instance as a doffed material or product of the carding machine. So that's why the production has gone up. The production efficiency has increased. The transfer efficiency has increased. Because of that, the production rate has increased. So this is the doffer, introduction of the doffer, which we saw in the basic discussion also. Most of the discussions, fundamental discussions which are needed, we have already done. At that time also I have stated this thing, that there are some changes which are helping the modern systems. They have been made, but overall the configuration of the card has remained the same, intact. There is no drastic change in that. So here now on the delivery side, a stripping device draws the web from the doffer here at 15. So this will draw means it will get transferred. After that, the calendar roller pair is there. The 16 here. Calendar roller pair, because the sliver has been, I have already shown in one diagram there, that asymmetric condensation on one side of the carding machine, on the in front of the dopper, the material will be conveyed through the strips, and then that will be drawn by a ruler, and then that will go away. By that time, the transfer of the material has taken place. It was fiber mass. Now we are required to condense it to the a sliver form. That's why this particular arrangement is there, and especially the calendar rollers which are used, they are condensing this material. They are condensing this material. So that's what is done. So what clothing is provided, that decides this particular thing, that regular interval it has required to be replaced from time to time, etc. That already we have discussed partly in the earlier session also. Now passage already we have seen, but let us go very quickly through this. Now this is a kind of a tubular system one can see here, or even we can see in case of the Ritter system also, that tube feed system is enhanced, changed. Some regularization is adopted here at this particular place, so that only regular flux will enter. Actually this I think this was introduced on C60 card by the Ritter. This three Likkerin system and cylinder dimension was also increased, something like that. So here again you have a sort of a screening mechanism here. So wire covered rollers are there, and then the feed system is there. The feed system, you have three Likkerins here, and three Likkerin, they will considerably reduce the flock size as one roller beats, and then gets the material gets transferred on the other roller, and then further it will be processed as usual in case of the either the conventional card or the card just now we have seen. And then this is the on the delivery side, you have the doffing mechanism here, the crush calendar rollers, and then further coiling arrangement and doffing system. So this is the quickly the passage of material through the modern carding machine. Again in this diagram we are seeing the same situation, how exactly what happens where these enhancements have been shown at feed zone. Exactly what is the situation that is shown in this diagram. We can see here this is going the feed roller and feed plate. This is the type of a conventional thing. This is not on the modern machine. This was back plate and front plate, and then in this Tickering zone, how transfer takes place. Less number of wire points on the Likkerin. On this cylinder, very high number of wire points are there, that already we had seen. Then carding will take place, and then here in this zone again, as compared to the cylinder, doffer will have some less wire points. PPSI, points per square inch, will be less on doffer, but they are very high as compared to the Likkerin, and then the further mechanism will operate here. So that's what is again the passage of the material through this one. Now modern carding installations, already we had seen this thing, just quickly we go through this one. Modern installations, card is first machine to deliver cohesive intermediate product. This product is expected to be very even, and as far as possible free from faults. Irregularities in this fiber can be traced through into the yarn. Therefore, at least in the spinning of the carded yarn, they diminish the yarn quality. Some of the what the meaning of this thing is, when only exclusively we produce a carded yarn, in case of them, some irregularities are seen, though we are taking the efforts to minimize them, but still they persist in some way or the other. So very quickly we go for the comparison of the conventional feed and different zones rather on the carding machine. A well-designed feed device is expected to perform following tasks: clamp the bat securely, able to hold the material back against the action of the Likkerin, and present the bat to the Likkerin in such a manner that opening can be carried out gently. So the gentleness of the action is we are required to expect it to have. In the conventional feeding system, how it is done, that is say depicted here. The feed dish plate is there, the feed roller is there, and then the Tickering or Likkerin will beat the material. So we have feed plate, feed roller, Likkerin, moat knives, Likkerin under casing. Under casing was there in case of the Likkerin, in case of the conventional system. In case of the modern system, already we have discussed about this one. The feed roller is having 80 to 100 millimeter dimension. Dimension plays a vital role. And then the feed plate, feed roller, and Likkerin unidirectional feed. This is especially in the context of the Ritter. Already we had seen this thing. The Tickering zone, now actually what exactly is there in case of the Tickering zone, we can see here. Already we have discussed this, but quickly we'll go through this one. Diameter of around 250 millimeters. Sawtooth clothing is applied on the takerin, and there is enclosure of grid elements or the carding elements. So they are there in case of this particular thing. So the finely opened flocks are fed, lead them into the dirt elimination parts under the rollers. This is what the suction, what I already discussed, to deliver them on the main cylinder. So this already we have discussed. Operating region of the card. So thickness of the bed, degree of openness of the raw material in the feedstock, degree of orientation of the fiber in the feedstock, aggressiveness of the clothing, distance between the devices, rotational velocity of the liquorine, material throughput. Already I have discussed the common points. What are the prerequisites of card in case of that one, but there are some few additional points here. That's why I have included them here. The thickness of the bed plays a vital role because thickness of the bed plus the regularity of the bed, this will play a vital role because based on that our point density has to be fixed, based on that our speed has to be fixed, etc. So these are the linked concepts to one another. Aggressiveness of the clothing means points per square inch on one roller, and in comparison with that points per square inch on the other roller, etc., etc. So these are the points which are required to be kept while we are studying the operation principle of the carding machine or operation overall of the carding machine. Actually this each point has again a very significant elaborate discussion that is to be made, but that is going to consume again a lot of time, so we'll go ahead. The main cylinder is usually manufactured from cast iron, but it is made up of stainless steel in today's situation. Diameter is around 1280 to 1300 millimeters, and it is rotated around 250 to 500 rpm. So surface speed of the cylinder, earlier they were of say 50 inches, now it has slightly gone up. So this indicates about the linear speed of the cylinder. Linear speed will definitely, when question of carding comes, what comes into the action, earlier I have also stated this, that the linear speed of the two parts which are taking place, interacting with one another. So it is essential that speed can be changed, that is exactly adapted to the requirement according to the raw material in the spinning process. That's why the cylinder speed is adjustable, and definitely it has impact on the yarn quality. Yarn quality, evenness, regularity of the yarn. So that directly has the bearing on that one. So that's why it is mentioned over here. Now one can say, see, read this thing. Below the cylinder, fully enclosing grid element, sheet metal provided with transverse slots. This is designed to remove the impurities and maintain the constant air condition. Now, here slightly we will discuss about the effect of air currents, since this point has come here. Air currents play a vital role not in carding but in case of the blowroom also. Though the gap is closed here in the cylinder zone, they are enclosed at Lickering zone also, at Doffer zone also. Only the material is slightly exposed, one can say, after the Doffer. Otherwise, this entire carding operation, right from the feeding to the Doffer delivery, from cylinder to the Doffer, it takes place under a, so to say, a vacuum. But if vacuum is created, there will not be any exchange of material. So air has to be there. I cannot go very say in depth about this one, but to mention here, air currents play a role in retention and release of the material. There is retention of the material that is necessary, as one can understand, on each of the part, on Licarin also, on the feed plate also, on the feed roller also. Retention is very important, and release is also important. Release is important for delivery from one rotating roller to the other rotating roller. So this is controlled by indirectly by the air currents which are going around each of this rotating part. So in a controlled way, airflow is required to be there in this machine. In case of blowroom also, as I have stated. So that plays a very important role. Like say, a very elaborate work has been done on this, and from there itself, these whatever adoptions are there by the manufacturers that have this kind of a metal here, this kind of a distance here, all these modern changes, and as I already mentioned, later people are monitoring the gap between the cylinder and flats continuously with the artificial intelligence. So this has become possible because the their continuous research on this one. This is true for, as it is true for the Ritter people, this is also true for Trussler people, and this is also true for LMW people also. All these manufacturers, they are doing their best to deliver their machines to the customers. There is no doubt about that. So, air currents. This was about air currents. Flats create a large surface area by clothing strips. Now, this statement is very important. Large surface area is created by flats. Long fibers have more contact with the clothing of main cylinder than the short fibers. Therefore, long fibers are carried along, but the short fibers are caught by the flat strip and they leave the machine. This is what is happening. As already I have stated in the previous session also, normally what waste is collected at the flat zone, flat strip waste, it comprises of short fibers and immature and dead fibers. This is the reason for that. So this elimination is carried out by filling the clothing, and the flats then passed by a cleaning device, that brush, etc. So this is what the phenomenon that is discussed here. We will quickly go through this diagram. There are two basic actions. In the first diagram on the left side, we have shown the carding action where point against point is interacting, and on the right side, the point against back is interacting, which is the stripping action. So this is what the operations are taking place in a nutshell. Separation of fibers from the tuft held between the two wire surfaces is called as carding action. There should be two very closely placed, this already we have discussed, 0.3 millimeters or 20 to 30 times the diameter of the fiber. Wire covered surfaces, wire points on each face, facing each other rather, point to point arrangement. Interaction of these surfaces should move either in opposite direction or in the same direction, that is the carding action. That's what is taking place here. Stripping again action, now exactly it is opposite of this one. Wire covered surfaces are required, they are closely required to be set, and they are required to move, but back, the point against back arrangement is very striking feature of the stripping action, which is taking place from Licarin to cylinder and from cylinder to the dopper. Between cylinder and flat, that is not a stripping action, it is carding action. This is very important point. So we'll move ahead. The doffer now, the doffing side, we have made lot of changes in case of this one. As we can see, the takeoff roller here, this roller is the takeoff roller which strips the material from the doffer. Then you have the delivery roller. Number 2 is delivery roller. Here there is a brush. This is the 6 is the cleaning brush. Number 5 is the suction system. Any waste that is gathered, this is above doffer we are seeing. This is above the doffer we are seeing here. Number 5 is the suction. This is the cleaning brush. This is the takeoff roller. This is the delivery roller. And this is the web collection center. Web collection to center. This one. Of course, here in case of this one, the central collection system is there. Number 3, web collection to center. Number 4 is the disk roller. Here we can see. And 5, the suction system, and the 6 is the stripping. So, in case of this one, this is the doffing mechanism on this one. Number 1 is takeoff roller. Of course, this is the doffer. This is the takeoff roller. Number 2 is the delivery roller. And number 2, there are of course 2 delivery rollers here. We can see these 2 up and down. So kind of condensation takes place here. This is a wire covered roller. Takeoff roller is a wire covered roller. The brush here is keeping this roller clean, and whatever brush is collecting, that waste is taken off. And here the web collection to center or asymmetric condensation, these beds, they will deliver to the further mechanism. So takeoff and sort of delivery rollers or crush rollers are there in case of this one. Now we can see here the doffer is normally 600 to 707 millimeters in the diameter. It is fitted with metallic clothing and runs around 300 meters per minute. This is very high speed, 300 meters per minute. That is the production rate of the doffer. Even it has gone up in today's situation. Detaching apparatus we have already seen here in the previous diagram. So we don't have any oscillating doffer comb here, but we have a proper doffing system, either a center collection system or asymmetric one-sided collection system that is provided. Each has its own advantages and disadvantages. So the plate, funnel or trumpet, which plays a vital role. Now there we are having the sensing mechanism there, as far as the what you can call the autolevelers are concerned. So that's cross-sectional view of the sliver can is there. We can collect either over-centered or under-centered collection system is there in case of this one. Normally we have over centered collection system in case of this one. This is discussing about the crushing rollers. Between the detaching roller and the transverse sliver condenser belt, some manufacturers include two smooth steel rollers. What number 2 we had seen in the diagram, earlier diagram, arranged one above the other. They can run without loading. They are loaded sometimes, so that they provide a very high degree of pressure there in between them. So sort of a crushing that can take place, or normalization of the web, condensing of the web, compacting the web, that is done by them. Now further in the end, we have the coiling mechanism. Normally in the conventional system, this we can see we were having the can also rotated and the top mechanism also was rotated. This was in the conventional system. Now in the modern drive, we don't have that kind of a system. Now this is overall, this it is difficult to explain a gearing diagram by sitting here, but this is the overview of the gearing diagram of the machine. So different manufacturers now have different ideas and different drive distributions are there, and their regularization is done. So this is a driving system of a car. Car clothing now, as it is stated here, clothing has the greatest influence on quality and productivity. Clothing, point density I have stated, point height is there, point angle, what we call rake angle, back angle. This variety of things are there, various things are there related to the exclusively to the card clothing. Now, a separate session is required to be conducted only on card clothing because it cannot be covered in a basic discussion. So, this what I can say here is the card clothing, various things are there which are optimized. As I have stated, the height of the card wire, which is provided on different elements, Lickerin, cylinder, dopper, etc. Wire height will be different, angle will be different, back angle will be different, their finish will be different. So various things are related to this particular thing. So rotational speed, production rate, material throughput, raw material type, natural or man-made fiber, fiber characteristics, overall quality requirements, price of the clothing. Of course, this is the managerial aspect, and service offered, again this is the managerial aspect. So overall quality requirement up to this, the choice of the clothing depends. Now clothing is required to be mounted on this cylinder, dopper and Lickerin. Card clothing mounting, grinding, finishing, burnishing, all these are again allied processes. In the conventional card, they were conducted in a different way. A different perspective was there. As I have stated in the previous session also, in case of the modern card, like Ritter's card, C81 or something, we are having continuous grinding, the classic and top online, the continuous grinding and continuous grinding for the cylinder and continuous grinding for the flats. So like that we have the changes. So now of course I had discussed very briefly about this one when I had discussed in the very beginning about the flexible clothing. The base will be firm, and then you have the point slightly flexible. Again, that rigidity or flexibility was again assessed, how much it should be there, etc. etc. So many considerations are there about this one. Semi rigid clothing and metallic clothing. Now universally on modern cars, metallic clothing is adopted. This particular thing depicts about the very conventional flexible clothing that was adopted on the very conventional card, one can say. We will just go through this one. We can see a semi-rigid type of a clothing. Normally, this is adopted, as I have already stated, this is used for the flats, and then a very firm clothing of various kind that is utilized on Lickerin, cylinder and dopper, depending upon what kind of function they are supposed to perform. So their cross section, their height, their angle, etc., their mounting, uh, sharpness of the teeth, various aspects are related to this. So this is a topic in itself. The cylinder wire are much smaller in size as compared to the dopper wire. Points per inch on the cylinder wire are higher than Doffer, which already I have mentioned for obvious reason that they are supposed to do the carding action, and Doffer is only supposed to receive these carded fibers. So the point density is slightly less, but its the point density is much more than the Lickering. The thickness of the ridge, etc., angle of the leading angle of the cylinder wire is more than the Doffer wire, etc., etc. Advantages of metallic clothing. There are various advantages. Their what I have stated, their retention and release. On most of the cases, this particular phrase I will be using specially. This is my own, say, generated phrase over the years. My what experience I have. Even I was using this particular phrase as far as the rotor is concerned. Rotor spinning is also concerned. The retention of the fiber on the rotors and their plucking off. The fiber pluck off, peel off of the fibers from the rotor. So retention and release, a very good trick to understand about, especially in the context of spinning. Now we'll go through this one. Most of the points, basic needed points we have discussed. So we will just say brush through this. Stripping is necessary because we are required to keep the wire points efficiency. They will perform better only and only if they are clean and they have retained their cross section, etc., etc. So these points are absolutely important. Now we'll say go through the card leveler again at a brisk pace. We have now produced, we are trying to produce the material. Earlier also in the beginning I have mentioned somewhere what is the necessity of the auto levelers on the card. So careful selection, uniformity is necessary in the spinning department to minimize sticky fabrics, waste of raw material, and the waste of production time. To minimize this one, we are supposed to use the auto levelers. Limitations of the traditional method of controlling the sliver uniformity, it is very high, you can say, because it was exclusively indirectly it was expected to be taking place. So need of auto leveler is continuous checking of the sliver weight together with automatic correction of the sliver weight variation at the card that is necessary. So variation is, we are trying here with the use of auto levelers on the carding to keep at the minimum the variation. So advantages of installation, they control the thickness, they followed the greater number of doublings, they generally cheaper. Classification, mechanical system, electronic system, open loop and closed loop, already we have discussed. In the open loop, variation is corrected in the draft zone by varying the speed of the output roller or input rollers on the draw frame, but correction follows measurement, so there is no check that correction was correctly applied. So open loop normally is done on the draw frame or delivery side of the carding machine, where very short processing length is there, and closed loop normally is installed between the feed zone and the delivery zone of the carding machine. So in the closed loop, what we have is variations corrected in the draft zone by varying the delivery roller speed. So measurement is done in the beginning and variation will be corrected at the delivery side, etc. So card auto levelers, they will be mounting long-term and short-term auto levelers, etc., or dual type of auto levelers, measurement principle, then correction. So speed and sensing, this is what the main theme of the auto leveling. Now this is, many a times we say that short term and medium term and long term. This is the correct definition of that. How far short and how far long? Very short term means up to 25 centimeters. Short term variation means 25 to 2.5 meters, 25 centimeter to 2.5 meters. Medium term variation means 25 meters to 250 meters, and very long term variation means above 250 meters. So we have various models which are adopted to take control of this variation, short term to very long term variation on the machine. Again, here we are required to understand this thing. Not only the sensing system has to be very efficient, but correcting mechanism has to have a very fast response. Then and then only short terms, I mean the autolevelers will work properly. So various developments very quickly we'll go through. Production rate has gone above 250 kilograms per hour now. Feeding system, FBK, shoot feed system, feed control system, correcta feed to regulate the feeding system, multi-liquoring system to take control over the fiber openness, precision flat setting, PFS, sorry, precision moat knife setting, PMS, aluminum flats without bolted connection, computer control with touchscreen, electronic flat measuring system, flat control TCNCAT, online NEP counting, NEP control, NCT, waste quality measurement system with waste control, WCT, digitally controlled maintenance system, servo drives, integrated card grinding systems, IGS tops for flats, IGS classic for the cylinder, magnetic flat bar, magnatop, the integrated continuous suction system, and then larger can sizes 1000 by 1200 millimeters roller doping system. Roller doping system. So these are in a nutshell the most recent developments on the carding machine. Now these are some of the references through which I have gone. I have already recommended my guides, Dr. R. Chattopadhyay, what he has written the book on the carding, fundamentals of the carding, and some other references are there. Now I sign off here today. I thank you all for watching, and please do share and subscribe this channel, share with your friends, and see soon in the next particular session. Thank you so much.